Hello, this is Mr. Collier, and today we're describing sequences and finding the next terms. So if we take a look at the sequence, let's find out what's happening here. What is the pattern? And if we look, we have 3, 7, 11, 15. So it looks like each term is increasing by 4. Okay, so we're going to describe that using the proper math vocabulary. And you should talk about the starting value as well. So you could say the sequence starts with or begins with 3, and each term is 4 more than the previous term. So that's one way to describe it. Okay, let's use the proper vocabulary term for each number in a sequence. Okay, and the next two terms are going to be, we're going to add 4, so you're going to get 21 and then 25. That's your next two terms. Okay, in the next example, this one's a bit trickier. It's not adding something each time because these numbers get really big really quickly. So it's going to be multiplying by something or to the power of something. If you look carefully at these numbers, and you might not recognize this, but these are actually the cubes of numbers. Okay, so one way you can see that actually is you can maybe, with your sequence, you could do this, right? This is the first term, second term, third term, fourth term. Okay? So what's happening here is you have 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64. So what's happening here is, well, these numbers up top are, we call it n, but we call it the term number. So what happens is the term number is cubed in each term of the sequence. Okay, so you could say each term is equal to the cube of the term number. Okay, now let's take a look at another couple of examples. So list the next 5 terms of the sequence. Now we don't have a list of numbers here. I don't know about the next 5 terms. I think that should be the first 5 terms. Okay, so we don't have a list of numbers here. What we have is 3n. So that's your rule. That tells you how to get your numbers. And remember, we can think of n as the term number. So you start with 1 and then go to 2, 3, 4, and we'll go to 5. Okay, so the first number is going to be 3 times 1, which is 3. Your second number is going to be 3 times 2, which is 6. Your third number is going to be 3 times 3, which is 9, and so forth. 3 times 4 is 12, and 3 times 5 is 15. So your first 5 terms of the sequence are 3, 6, 9, 12, 15. Okay, in the second example, the rule is 2 times the number plus 1. So you can set this little chart again, I guess. 1, 2, 3, 4, 5. And you do 2n plus 4, so you do 2 times 1 plus 4 is 6. 2 times 2 plus 4 is 8. 2 times 3 plus 4 is 10. And you can already see a pattern in these numbers, so you can just fill out the rest of the numbers. These numbers are increasing by 2, so you can fill in the rest of the numbers. So the first 5 terms of this sequence are 6, 8, 10, 12, and 14. Okay, and one final example. This says, which of the following is an arithmetic sequence? So that is just a fancy word for, let's say, each term increases by a constant, well, actually we can just say constant, a constant value, I guess. Okay? So they're asking you, does each term increase by constant value? Well, to go from 2 to 5, you have to add 3. From 3 to 8, sorry, 5 to 8, you add 3. From 8 to 11, you add 3. So yes, it is increasing by a constant rate. So it is arithmetic. Okay. Next one. Now, are we adding something each time? Well, the seems to be going down by 5 each time. You could say that is adding a negative 5 each time. So you add negative 5 each time to get each next term. So yes, it is also arithmetic sequence. So it is arithmetic. And the last one, let's take a close look at this one. It's not obvious by looking at it. Here, from 3 to 8, you add 5. 8 to 13, you add 5. And 13 to 19, that's actually add 6. 19 to 24 is adding 5. Now, they're not all the same. There's one difference, and that's all it takes to make it not arithmetic. So this is not arithmetic.